Hi, hello friends, welcome back to our channel. In this video I'm going to discuss about the egg white protein. So what does this egg white protein consist of, and what that actually present in this egg white. So as there are many proteins present in this egg, though it is called as albumin. So egg white proteins are called as albumins. So these actually are globular in shape, are important for the forming properties of the egg white. So egg white proteins are responsible for the forming properties of the egg. So next, so what are the enzymes and what are the proteins that which are present in the egg? Or first, it is lysozyme, enzyme capable of lysing the cell wall of the bacteria. So it will break the cell wall of a bacteria. So indirectly we can say that this enzyme is responsible for killing the bacteria that which enters the egg. Okay, so the enzyme is much more heat sensitive in egg albumin than alone. So when it is in combined with the egg albumin or present inside the egg albumin, it is heat sensitive. When we heat it, when it is present in the egg albumin, it get destroyed. Where when it is alone, means it is in alone, single, so it is strong. So when it is in egg albumin, it is heat sensitive. When it is alone, it is strong, and means it is heat stable. Okay, and lysosome has a four uh, disulfide linkages, means it has four disulfide linkages. Okay, and is well characterized enzyme. Next, coming to the ovomucoid, so consisting about 10%. So whole the egg white protein, it is about 10%. It is available in three forms, which are trypsin inhibitors, which act as a trypsin inhibitors, and carbohydrate moiety of protein has the hexoses. So what is this hexoses? Galactose is a hexose and mannose is a hexose. So it will having the it will combine with the actually this ovomucoid is a mucoid is a protein, right? So it will combine with the carbohydrates. So what are these carbohydrates? Means hexoses. So what are these hexoses? Galactose and the mannose, right? And protein has 8 disulfide linkages, so it has 8 disulfide linkages, whereas lysosome has 4 characterized disulfide linkages, where it has a 1 2 3 4 5 6 7. So it is having 8 characterized disulfide linkages. So and it is acid resistance. So when it is kept in the acid media, so it is heat resistant to denaturation, so it will not get denaturated where it is acid resistant. So then next, moving on to the avidin. So what is this avidin? So avidin is also a protein that which is present in the egg white. Avidin composed of three components. So what are these? Avidin A component, avidin B component, and avidin C component. It binds to the biotin and makes the vitamin unavailable. So when we are taking the food rich in the vitamin B7 biotin, so it will make along with the combo with the avidin, sorry, with egg, so that will egg white protein avidin will make the unavailability of the vitamin biotin. So when we are when we'll eat this food, so this makes the availability of the vitamin. Why? Because avidin is easily denatured by the heat. Okay, so this is important. And next, moving on to the conalbumin. It is about 13%, and it is more susceptible to the heat coagulated and less susceptible to surface denaturation than ovalbumin. So it is easily coagulated. Means when we are heat it get when we heat it, it get coagulated. So like it get jelly form, right? When we heat the egg, so when we keep the egg white on the pan, so when we heat it, so the egg white will become like thickness, and it will get sagging qualities, like it will get elastic qualities. So it is called coagulation. So it is easily get coagulated when it is exposed to light of the very low amount of the heat, so it will get easily coagulated, and it is less susceptible to surface denaturation. So where the proteins will will not get denatured with the in the surface, so denaturation will not occur, like a protein will not get break into the amino acids, so they will not get denatured on the surface. Then ovalbumin is highly susceptible to the surface denaturation. So and the protein easily binds with metallic ions such as ferrum, aluminium, copper, and zinc. So all this, it will combines with these metals like ferrum, aluminium, copper, and zinc, and form the heat stable complexes. So this is about conalbumin. It constitutes of 13% of a whole egg. And coming to ovalbumin, it is one of the most important and high constituents of egg white protein. So it is a phosphoglycoprotein, and it has three components. It is, what is this phosphoglycoprotein is actually means? So the protein is having phosphorus and also glucose. So it is a moiety having phosphorus, glucose, and the protein. So has it has three components in it. A1, if we are considering as three components as A1, A2, A3. So these are these three components are present in ovalbumin, but they are differ in the composition of the content of P, means phosphorus. So one is having two phosphorus, one is having one phosphorus, one is having no phosphorus. So one having 1 2 3 like that in the way. So they are differ in the composition of the phosphorus, and all the components of the sulfhydryl and disulfide groups. So these components will having the sulfur and disulfur groups in their components, and carbohydrate components of ovalbumin or mannose and glucosamine. So what is the content? It is about 5. If you are having mannose of 5, glucosamine will be 3, and if you are having if mannose is 10, then it will be 8. So the composition will be changes. Okay. Mechanical agitation will denaturate these ovalbumin. Next, coming to the ovomucin. Ovomucin, it is responsible for thickness of albumin, so it's most important thing. So what is the egg white protein that is responsible for the thickness of albumin? So it is ovomucin, more than the thin layer. So it is more in the thick layer compared to the thin layer. So insoluble in water but soluble in dilute salt solution. So ovomucin is insoluble in water but soluble in these solutions, and it has 3 components resistant to the heat denaturation. So, and between a pH of 7.1 to 9.4, heating for 2 hours and 90 degrees centigrade is not bring about any change. So ovomucin plus lysosome can form the water salt complexes, so it will form these complexes. And next, coming to the other proteins, egg albumin has other proteins like flavoproteins, ovoglobulin, and excellent forming agents like ovoinhibitors. So all these were the proteins that which are present in the egg. So egg white. So lysozyme is an enzyme which will break the cell wall of the bacteria and ovomucil. It is a trypsin inhibitor and it is constituents about percentage, and iodine it acts as a unavailable iodine which makes the biotin unavailable, and also conalbumin which constituents about 13% of egg white protein, and it has a phosphorus, and it is having neither phosphorus or sulfur, whereas ovalbumin is having phosphorus in their component and glycogen and also protein, and they are having 3 components that differ in their phosphorus component content, and ovomucin which is responsible for the thickness of the albumin, and it has 3 components are resistant to the heat denaturation, where ovomucin and lysosine can form the pure form of the water and water soluble complex, and other proteins are flavoproteins and ovoalbumin and other proteins are flavoproteins and ovoglobulin, and it has 2 components like globulin 1 and globulin 2, and which are responsible for the forming agents. So excellent forming agents. Actually we say that egg white proteins are rich in forming properties, so in that particularly we can say ovoglobulin are very responsible for the forming properties of egg white. Okay. And next, coming to the ovo inhibitor, chemo and trypsin inhibitor. So this is about the egg white protein, friends. So I think you got the video. So this is about the video, and thank you.